Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have discussed first four problems from exercise 13.2. Hope it was clear for you all. And in today's session, we shall discuss the remaining four problems from exercise 13.2. Let's move on to the topic. Before starting the session, let's recall the formulae from the chapter surface area and volume. The first shape is cuboid. Length is represented by the letter L, breadth is represented by B, and height is represented by H. Then the volume is L into B into H. Lateral surface area is 2H into L plus B, and the total surface area is 2 into LH plus BH plus LB. Next shape is cuboid. The side of the cuboid is represented by the letter A. Then the volume is A cube. Lateral surface area is 4a square and the total surface area is 6a square. Next is a right circular cylinder. The height of the cylinder is represented by the letter H and the radius is represented by the letter R. Then the volume is pi r square h. Lateral surface area is 2 pi r h and the total surface area is 2 pi r into h plus r. Next one is a right circular cone. The height is represented by h. Radius is represented by the letter r. And the slant height is represented by the letter L. Then the volume is 1 by 3 pi r square h. Lateral surface area or curved surface area is pi rl and the total surface area is pi r into L plus r. Next shape is sphere where the radius is represented by the letter r. Then the volume is given by the formula 4 by 3 into pi r cube. Curved surface area is 4 pi r square and the total surface area also the same formula 4 pi r square. Next shape is hemisphere. Like the previous one sphere, here also radius is represented by the letter r. Then the volume is 2 by 3 pi r cube and the curved surface area is 2 pi r square and the total surface area is 3 pi r square. Exercise 13.2, question number 5. A vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Let's go through the question again. A vessel is in the form of an inverted cone. Inverted cone in the sense just keeping the cone up down. Normal cone, the base is circle and the circular portion is down and the vertex is upside. That is a normal cone. Inverted cone in the sense just opposite, means circular portion is upside and the vertex is down. Height of the cone is given to us 8 cm and the radius which is given to us 5 cm. And one more condition is given, the upside, the top is open and it is filled with water up to the brim, means till the top it is filled with water. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, means there are several number of lead shots and the radius are given, that is 0.5 cm. It is dropped into the vessel and while dropping 1/4 of the water flows out. So since the water is up to the brim, when you drop a particular number of lead shots, surely there will be no space and some amount of water should go out. So that is given to us 1/4 of the water which is inside is flowing out. Find the number of lead shots dropped in the vessel. You have to find out how many number of lead shots we are dropping in. So let's visualize the question. So there is a vessel, conical vessel, radius is given to us 5 cm and the height is 8 cm. There are several number of lead shots we are dropping in and the condition is when the number of lead shots are coming in, 1/4 of the water which is inside is going out, since the water is filled up to the brim. Here we have to find out the number of lead shots. Let it be n. Let the number of lead shots dropped in the water be n. And here there are two shapes it is mentioned. One is conical vessel, means cone, and another one is lead shots, means sphere, spherical balls. Let's write down the measurements. First, cone, radius is given to us 5 cm and the height is given to us 8 cm. And in case of lead shot, means sphere, only one dimension, that is radius 0.5 cm. And as per the question, here volume of lead shots which we are dropping in will be same as volume of water flown out. As I mentioned before, water is filled up to the brim and there is no space, there is no free volume inside, and when there are number of lead shots dropping in, the same quantity or the same volume of water will go out. So that is what it is mentioned, volume of lead shots is equal to volume of water flown out. Here volume of lead shots, that means it is spherical in shape, and here volume of water flown out in the sense water is inside the conical vessel. So we need to find out the volume of cone as well. So let's recall the formula. Volume of sphere is 4 by 3 pi r cube, and here the volume of cone, that is 1 by 3 pi r square h. So these are the two formulas we are going to use. That is n into volume of one lead shot. There are several number of lead shots we are dropping in. We don't know how many, so that we are taking as n into volume of one lead shot, because all are in same size and shape. That is equal to 1 by 4 into volume of water flown out. That is 1 by 4 into volume of cone. It is mentioned here 1/4 of the water flows out. That is 1 by 4 into volume of cone. Let's substitute it. That is n into volume of one lead shot, that means sphere. 4 by 3 pi r cube is the formula. 4 by 3 into pi into radius is given 0.5, the whole cube, is equal to 1 by 4 into volume of cone. That is 1 by 4 into volume of cone formula is 1 by 3 pi r square h. That is 1 by 3 into pi into radius is 5. So 5 square into height is given h. So 5 square into 8. Then let's calculate n is equal to, here just there are common terms we can cancel on the right side and left side. Here there is pi is common and here there is pi. So this two we can cancel. So just cancellation you can show it in your notebook. This pi and this pi can be cancelled. This 3 and this 3 denominator, common denominator, can be cancelled. There is no other cancellation is possible right now. So just we can take the remaining quantities to the right side. Since here all multiplication, when this numerator comes to the right side, it comes as a denominator, and here this denominator comes to the right side, it goes as numerator. So here in the denominator 3 is cancelled, so there is only 4 is balanced, so that is written 4, and from here numerator there is a 4 that will come, and here 0.5 cube, 3 0.5s are there, that will come here, 0.5 into 0.5 into 0.5. So these all numerators comes here as denominator, and here there is a 4 that is also included. And here on the right side pi is gone, there is 5 square is there, so 5 into 5, this one also there. Then here there is 8, and here there is no denominator, there is only one denominator 3 that was cancelled, so nothing to come from here to the numerator. So this is the calculation we have to do. Here decimal numbers are there, just remove that decimal by multiplying 1000 on the numerator. That is 1000. Why we are multiplying? In the sense, here after the decimal 1 digit, here 1 digit, here 1 digit, so total 3 digits after the decimal. So 3 digit means we have to multiply 1000 in the numerator, then denominator will, the decimal portion will be removed. So 1 into 5 into 5 into 8 into 1000 divided by denominator is 4 into 4, and this 3 will come as 5 into 5 into 5. Now here also cancellation I am not showing, but I will explain it. You have to show it on the notebook. Here 2 5s are there, and these 2 5 also cancelled. And here 1 4 and 8 we can cancel, 2 is the balance. The 2 and this 4 can be cancelled, 2 is the balance. And this 2 and here 1000, when you cancel it, you will get 500. And this 500 and this 505, when we cancel, we will get 100. Once again, here 5 and 5, 2 5s are there in the numerator. Denominator also 2 5s are there, that 2 can be cancelled. And here there is 4, and this 4 and the numerator 8 can be cancelled, 2 will come. That 2 and this 4 can be cancelled. So here 2 will get, that 2 and this 1000 can be cancelled. So 500 will get, that 500 and this 5 can be cancelled, 100. So finally you will get as 100. So this is my way of calculation. You can just do it your own calculation, the way you supposed to do, which is convenient for you, that you can follow it. It's not a problem. But you should get the answer n is equal to 100. That means number of lead shots we must get it as 100. Hence, there are 100 such lead shots. How many such lead shots we are dropping in? So, there are 100 lead shots we are dropping in. Move on to question number 6. A solid iron ball consists of a cylinder of height 220 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the ball given that 1 cubic centimeter of iron has approximately 8 gram mass. Value of pi is also given. Pi is equal to 3.14. Here, let's go through the question again. A solid iron pole consists of a cylinder of height 220 and diameter 24. Here, solid iron pole means a pipe consists of, or pipe or post we can say, consists of a cylinder, and the dimensions are given to here, which is surmounted by another cylinder. Means there is a cylinder and on top of that another cylinder is there, and the dimensions are 60 and 8. When you compare the dimensions, the first one is the bigger cylinder because the dimensions are big, and the second one is a smaller cylinder. Here the dimensions are smaller when we compare it with the first one. We are asked to calculate the mass of the ball, and given that 1 cubic centimeter of iron has approximately 8 gram mass. This is called the rate. 1 cubic centimeter is having this much weight. That means we have to find out the total mass of the ball. Value of pi is given to you here. Let's visualize the question. The first one is a bigger cylinder, as I mentioned before. 24 is the diameter and height is 220 centimeter, and the smaller one, surmounted in the sense just keeping on top of another one. Height is 60 and radius is 8 centimeter. So let's write down the measurements. Small cylinder, radius is 8 and height is 60. For the bigger cylinder or large cylinder, radius is 24 divided by 2, that is 12, because it is diameter 24 and height is 220 centimeter. So volume of pole means it is quite clear because we have already calculated this type of questions. Just add the volumes because one is on top of another one. So we have to add the two volumes. Volume of small cylinder plus volume of large cylinder. Let's recall the formula for volume of cylinder, that is pi r square h. Let's substitute it, that is pi r square h. Pi value is given to us 3.14, means you should not substitute 22 by 7. You have to use this 3.14 only. If 3.14 or the pi value is not given to you, then you can use 22 by 7. So 3.14 into 8 square, radius is 8 square into height is 60, plus again the same formula, 3.14 into radius is 12, so 12 square into height is 220, so into 220. Here there is no other calculation is available, cancellation is available, so just do the multiplication, that's all. While doing multiplication, try to write it in 2-3 different steps because it reduces the mistakes. When you do it all together in single calculation, it creates a lot of confusion. Then just 3.14 into 8 square is 64 into 60 plus 3.14 into 12 square is 144 and 2 into 220. And these three numbers, if you multiply, you will get as 12,057.6 plus these three, when you multiply, you will get 99,475.2. And please do not copy this one. You have to do it on the right side of your notebook, this calculation, and verify that you are getting this answer. And remember, also avoid just doing the calculation just behind your notebook. Do it on the right side of your notebook. When you send the note, it must be there, the calculation part. When we add these two, we will get 111,532.8 centimeter cube. This is the volume. We are asked to calculate the weight or the mass. So mass of the pole is equal to volume into rate. Volume in the sense we have got here volume, and the rate is for per centimeter cube how much, that is the rate. So 1 centimeter cube is having 8 gram mass. We are having this much centimeter cube. So volume into, that is, it is given to you here, into 8 gram. 8 gram in the sense the unit is here gram. Just we will convert this one into kilogram because it is when we calculate you will get a bigger quantity. So let's change the unit gram to kilogram. So for converting gram to kilogram, you have to divide with 1000. So 8 by 1000 kilogram. Then Just to multiply the numerator, that is you will get the numerator as 892262.4 divided by 1000. And here division with 1000 is quite simple. There are 3 zeros, so you move the decimal 3 places to the left. So you will get as 892.2624 kilogram. That is the mass of the pole or weight of the pole. So just we can round off this one to 2 decimal places, that is 892.26 kilogram. Exercise 13.2, question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. When the volume of water left in the cylinder, if the radius of the cylinder is 60 cm and its height is 180 cm. Let's go through the question and let's identify the given conditions and the given shapes. A solid consisting of a right circular cone, there is a cone is given to us, dimensions are given, standing on a hemisphere, dimensions is given. So here the solid is consisting of two shapes mentioned here. One is a right circular cone standing on a hemisphere. So there is a hemisphere on the bottom, on top of that there is a cone. And we are keeping just this solid inside a right circular cylinder which is having full of water. We are asked to calculate the volume of water left in the cylinder if the cylinder is 60 cm radius and height is 180 cm. So just in the previous question we have discussed this matter. Means you are asked to keep a particular solid inside another shape which is having full of water. That means once you dip a particular solid inside another solid or another shape which is having full of water, some quantity of water will flow out. That quantity of water which is flowing out or the volume of water which is flowing out will be same as the volume of that particular shape which you are dipping in, particular solid which you are dipping in. So that condition only here we have to use. Let's visualize the question. There is a cylinder, dimensions are given, height 180 and radius 60, and there is a solid which is having hemisphere on the bottom and cone is on the top, and that particular solid you are placing inside the cylinder which is having full of water, and there are some, of course, some quantity of water will flow out of this cylinder. That volume of water which is flown out will be same as the volume of this solid. We are asked to find out the volume of water left in the tank or left in the cylinder. So volume of water left in the sense, how we calculate in the sense, just volume of cylinder minus volume of this solid, because volume of this solid or the quantity of water which is flown out will be same as volume of this solid. So when we subtract from this volume of this cylinder minus volume of this shape or this solid, we will get the volume of water which is left in the cylinder. Let's write down the given shapes dimensions. Cylinder, radius is 60 cm is given and the height is 180 cm. And next is cone. Cone is having radius 60 cm and height is 120 cm. And the next one is this portion, hemispherical portion. Only one dimension, that is radius 60 cm. As we have discussed before, volume of water left in the cylinder is equal to volume of cylinder minus volume of solid. Minus in the sense that much volume of water will go out. So previously this cylinder is having full of water, that's why we are taking volume of cylinder minus how much quantity will go out in the sense volume of this much, volume of this solid shape, that much quantity will flow out. That's why we are subtracting minus volume of solid. That is equal to volume of cylinder, we know the formula, pi r square h, and volume of solid. Volume of solid in the sense we are having cone and hemisphere. So cone formula is 1 by 3 pi r square h and volume of hemisphere is 2 by 3 pi r cube. We have already learned these formulas. Just substitute it here. That is pi value, pi r square h. So pi value is 22 by 7 into radius. Radius is 60 square. Radius of cylinder, that is 60 square, into height is 180, minus cone formula is 1 by 3 pi r square h. So 1 by 3 into pi value. Pi value is 22 by 7 into cone radius is 60. So 60 square into height of the cone is 120, minus hemisphere. Hemisphere we have only one dimension, that is radius. Formula is 2 by 3 pi r cube. So 2 by 3 into pi value 22 by 7 into r cube is 60 cube. Here there are two minuses are coming. How it came in the sense, just I am doing all in single step. Volume of cylinder is this one. Volume of solid means minus of these two volumes, hemisphere volume plus cone volume. Since here minus is there outside the bracket, just we have to multiply inside. That's why these two also came as minus. Then 22 by 7 into 60 square is common. Here you can see 22 by 7 into 60 square. Here also 22 by 7 into 60 square. Here also 22 by 7 into 60 cube is there. So square we can take out. So 22 by 7 to 60 square if you take out. Here there is only 180 balance, minus, and here 22 by 7 into 60 square is out. So 3 and 120 we can cancel. So we will get the balance 40. So that came here. And here also 22 by 7 to 60 square is outside. So there is only 160 into 2 by 3. So this 3 and 60 we can cancel 20. So 20 into 2, 40. So 180 minus 40 minus 40. You have to do the calculation or cancellation in the notebook. That is equal to 22 by 7 into 60 square, means we can write 60 into 60. 180 minus 40 is 140. 140 minus 40 is 100. Then just multiply it. Normal cancellation is not possible. Just to multiply all the numerators. When you multiply numerator, you will get 7920000 divided by denominator is 7. When you do the division, you will get as 1131,428.57 centimeter cube. Here 1131,428.57 centimeter cube. If you want to change the unit, you can change it. It is not compulsory because here centimeter is mentioned, all the unit. So if you want to keep, you can keep as it is. Here I am changing centimeter to meter cube, but it is not mandatory. For changing centimeter to meter, we have to divide with 100. Centimeter cube to meter cube, if you want to change, we have to divide with 100 cube because there is cube. Centimeter to meter only divided by 100. Centimeter cube to meter cube divided by 100 cube. Just I have divided. So you will get the answer as 1.131 meter cube. 100 cube in the sense there will be 6 zeros after 1. 6 zeros in the sense we can change this decimal to 6 digits to the left. 1, 2, 3, 4, 5, 6. So 1.131 meter cube. Now you can see it is somewhat reduced to 1.131. Previously it was a bigger number. So for that purpose only we have changed the unit, but it is not compulsory. Now the volume of water left in the tank is 1.131 meter cube. Move on to question number 8. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in diameter. The diameter of the hemispherical part is 8.5 cm. By measuring the amount of water it holds, a child finds its volume to be 345 cm cube. Check whether she is correct, taking the above as the inside measurements, and pi is equal to 3.14. So the shape is given to you. Spherical glass vessel has a cylindrical neck 8 cm long and 2 cm in diameter. And the diameter of the spherical part is 8.5 cm. Let's visualize the question. So the spherical part is here and the cylindrical neck also mentioned. It is a glass vessel. You might have seen this type of shapes in your house. So this is the shape given to us. And a particular child is measuring the amount of water it holds. What she measured is the quantity of water which is there, which can be placed inside this vessel. She measured and she found that the volume is 345 centimeter cube. You are asked to check whether she is correct or not by taking above as inside measurements. By using these measurements, you have to calculate the volume and you have to compare it with this one and you have to check whether this one is correct or not. How the child measured, in the sense she measured the quantity of water which is kept or which can be filled inside. By measuring only, she got 345 centimeter cube. You are asked to check by using these measurements. So let's write the given shapes, that is cylinder, dimensions radius is 2 by 2, that is 1 centimeter, half of the diameter. Then height is 8 centimeter, it is given to us. And next is a sphere, this is the portion, and the spherical one, radius is 8.5 is the radius, just divide it 4.25. You can divide because here value pi value 3.14 is given to us. So anyway you have to multiply. So no need to keep it as fraction, just divide it and keep. Volume of vessel is equal to volume of sphere plus volume of cylinder. Volume of sphere, we know the formula, 4 by 3 pi r cube. Volume of cylinder pi r square h. Let's substitute it. Volume of sphere 4 by 3 pi r cube. 4 by 3 into pi 3.14 into radius. Radius is 4.25 centimeter. That is 4.25 cube. Plus volume of cylinder pi r square is the formula. Pi value is 3.14 into r. Radius is 1 square. Height is 8. So we have just substituted. The rest of the part, the calculation part, you have to check it by your own. Just to multiply it and add, then find out the answer, and you have to compare it, that answer, with this one and check whether this answer is correct or not. So that part you will do it as homework. Students, today we have completed exercise 13.2. I request all the students to go through this exercise and solve these questions independently in a sheet of paper. While solving, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.